Imagine you're a space traveler exploring the cosmos. You stumble across a black hole and decide to take the leap, diving straight in. Despite the name, you wouldn't be falling into an empty pit. A black hole is actually the exact opposite of empty space. It is the remnant core of a massive star that died and collapsed entirely upon itself. Picture 4 of our suns packed tightly together, squeezed down into a sphere just 15 miles across, a distance you could drive in 30 minutes. The mathematical framework for this extreme concentration of mass was first predicted by Albert Einstein through his theory of general relativity. Crossing into this region places you in an environment where gravity becomes the absolute governing force of your reality. Because that mass is packed so tightly, its gravitational pull traps everything. Even light cannot escape its grip, making the core completely invisible to us. We only know these objects are there because of the gamma-ray bursts they emit. These bursts were discovered by physicist Stephen Hawking and now carry his name, Hawking radiation. The absolute boundary of this trap is called the event horizon. This is the exact point of no return, where the inward pull of gravity becomes completely insurmountable. Once you pass the event horizon, the laws of physics diverge. Our shared experience of time and space shatters into 2 completely different, contradictory realities. To actually see what happens on the inside, you have to survive the initial fall, and that requires picking the right target. With a common stellar black hole, gravity pulls harder on your feet than your head, stretching you apart in a fatal process called spaghettification. To survive, choose a supermassive black hole. Its massive scale equalizes the gravitational force, letting you drift across the event horizon intact. You wouldn't even have to leave our cosmic neighborhood to find one. There is a supermassive black hole sitting right at the center of the Milky Way galaxy. But keeping your body intact is only the first physical hurdle. The true horror begins inside, as the basic mechanics of the universe begin to warp. Let's look at this entirely from your perspective, the traveler, now floating in the dark inside the event horizon. You have entered a spatial paradox, where space and time literally swap roles. Trying to turn around and move toward the exit is physically impossible, exactly in the same way that traveling backward in time is impossible on Earth. Your future is now a physical direction. You are locked into a relentless, one-way plunge toward the absolute center of the void. That center is the gravitational singularity. It is a mathematical anomaly where density becomes infinite, and all incoming matter is completely compressed and squashed together. So for you, the journey is strictly linear. It has a definitive and fatal end right there at the core, destroying your physical form. But that is only your version of events. Let's switch to the perspective of a friend watching your journey safely from outside the event horizon. Your friend never actually sees you cross into the darkness. Instead, as you approach the boundary, they watch your movements drastically slow down. Your image gets continuously dimmer and shifts into a deep, dark red. This split data visualization shows exactly what happens to your image. While the color spectrum shifts straight to the red line, your velocity drops completely to 0. To your friend, you freeze permanently right at the outer edge of the event horizon. This optical illusion happens because relativity dictates that time itself comes to a complete standstill at the event horizon, relative to an outside observer. A single cosmic event results in 2 contradictory truths. You are completely crushed at the center of the singularity, while simultaneously existing eternally frozen in time at the very edge. Eventually, over trillions of years, the black hole will die. It will evaporate, emitting every single particle it ever absorbed back out into deep space. But this creates a severe problem for physicists. When those particles finally exit, the specific physical information that originally built your body is entirely lost, scrambled beyond recognition. Stephen Hawking spent years wrestling with this missing data dilemma and eventually proposed a mathematical solution. He suggested that black holes might act as connection points. The information isn't destroyed, rather it fragments out into alternate universes that run on entirely different historical timelines. If reality actually forks at the singularity, your core biological data is never deleted. It simply gets rerouted to a universe we have absolutely no way of measuring. According to this theory, there might be a parallel timeline, represented perfectly by a peaceful Earth, where that black hole never formed at all, and in that reality, you are still alive. The tragedy is that these timelines are permanently disconnected. Even if a healthy, living version of you survives in another dimension, you can never bridge the gap to return and report back. These objects represent localized points where our absolute certainty in time, space, and a shared reality breaks down completely. At the extreme edges of the universe, reality is not a single shared truth. It depends entirely on where you are standing.